Alright, so now we are in the Calvin cycle. Yay!
Okay.
Also known as the light independent reactions.
Carbon fixation, triose phosphate. I think we're going to go to the reduction.
Oh, we're starting?
We still have the other video.
Okay.
Okay, go over from Rubisco's a matchmaker, and then we'll continue.
Alright, so, Rubisco is that matchmaker that he is an enzyme that catalyzes CO2 and RUBP's relationship. But he's the kind of matchmaker that sucks at his job. Because they split up, and as a result, you're left with 3,6-carbon short-lived intermediates, meaning that these 3,6-carbon are not going to be around for long. Because as you see, they split in half. And, 6 divided by 2 is 3, leaving you with 3 phosphates, right? Well, as a result, that's 6 G3P. You've probably seen those around before.
Yes.
Okay.
I just think that's where the 3-phosphate come from, but those have 3 carbons.
Well, I'm not going to
It's
get
okay.
into it. TP. Never mind. Alright. So, reduction. Each molecule of the triose phosphate, or each molecule is converted into triose phosphate, and you need 6 ATP and NADPH for this. That was made back in the light dependent reactions.
Yes, by our good friend ATP synthase.
Exactly. And these two will convert the G3P into triose phosphate.
Yay!
Because this is a cycle, keep in mind. So what you start with is what you're going to end with. So of course you're going to end with triose phosphate if that's what you start with. So anyways, the triose phosphate is used to make one of them of the triose phosphate is used to make sugar, like glucose or fructose.
I think I figured out where we're getting confused.
Where?
Triose phosphate, you don't start this with triose phosphate. You're making triose phosphate out of this.
Yes, but you
In the beginning, you said it's like, we're going to make them, and it goes through one at a time. But that's only talking about the CO2. Triose phosphate's what's made.
Then we need to restart this.
No, we don't.
Yes.
I just explained it. We didn't say a lot. We kind of beat around the bush on it. I'm trying not to talk about it because, we didn't understand. But yes, we're making triose phosphate.
Okay. So, of the 6 triose phosphate that is made, one of them goes off to make sugar, glucose and fructose.
Okay.
So their little baby, one of them is going off to be on sweet land, blah blah blah.
Yay!
And one of them is successful. The others are somewhat successful, but not as.
They have
And
to go back home.
yeah, they have to regenerate RUBP. They have to take care of their dad because he's kind of dying
And lonely.
and lonely.
So,
So, yeah.
CO2 left him.
Alright, now the
Okay.
last stage is RUBP. And the 5 children of RUBP,
The 5 triose phosphate that are left
yes,
are rearranged.
are rearranged, molecular rearrangement for 3 RUBP.
Cool.
Yeah, and 3 ATP is used in that process. That's the shortest stage. So, a summary of what is made is you have the 3 CO2 and carbon fixation is converted into 1 triose phosphate. Then wait, why did it say that?
Okay.
It's 6.
This cycle requires 1 CO2 to run the cycle. But to get triose phosphate, you have to go through the cycle 3 times. So you need 3 CO2 to get 1 triose phosphate.
Exactly.
In order to get 1 glucose, you have to go through the cycle. You can't see my pinky, but I have Caroline hold up a finger. You need 6 CO2. That's what she was trying right there.
Okay. Yes. So, in the end, 9 ATP are used and 6 NADPH are used. And then keep in mind that one of those triose phosphate is going down to sugar making. And that's
Gonna make some sugar.
that is the Calvin cycle.
Yay!
Bye.
Bye-bye.